My name's Troy Smith. I'm New Business Development Engineering Manager for Kawasaki Engines, and I'm here today to share with you our conceptual engine, our GeoTorq engine. It's a new platform for us that we are looking into. It's an engine that we are capable of providing additional fuel systems and additional technology into the industrial and commercial engine space. So our GeoTorq engine is based off of a 2.4 liter engine, and with this, it is a flex fuel capable engine, and we are able to provide a fuel system compatibility between E0 up to E85, and there's some benefits there along with the enhanced performance of E85. We can look at reducing carbon with this engine. So this engine is based off of an industrial grade engine. It has a cast iron block. It utilizes a heavy rotating assembly. It has a aluminum head for better cooling and heat rejection. And then it builds off of our current electronic fuel injection technology, where we're able to control the fuel, the air, and the spark independently to be able to tune the torque of that engine for the best power possible. With this engine, it reduces emissions by being able to offer the E85, so we can reduce carbon as well. And then it also simplifies after treatment. So with this engine being gasoline up to E85 compliant, we can utilize a three-way catalyst in order to be compliant for emissions. And in a comparative diesel engine, that eliminates those heavy cost aftermarket or heavy cost components to the after treatment. So we can eliminate DPF, potentially SCR, high pressure common rail, and be able to provide equivalent power and torque in a much simpler package. This engine is a platform that allows us to expand into other possible engine sizes. So today we're displaying a 2.4 liter engine. That engine is would be available in a naturally aspirated version along with a turbocharged version. And this map here kind of gives a roadmap to potential future. So we've got some performance profiles for both E10 and E85. As we get into the E85, there's some additional advantages to reduce NOx during using that fuel, which allows us to run some additional timing and to increase the power of that engine as well. So this leads into the naturally aspirated, the turbocharged, and then future engines could be even larger size, potentially a 3.6, 4.2. So it gives us a platform with this fuel injection technology and with this fuel system to expand into those other engine size categories. And then being flex fuel capable with the electronic fuel injection, it allows us to not only be gasoline variations, but also sets a platform for the future where the ignition timing or the ignition system the combustion system needs to be set up for hydrogen. So we have some current products in the market today through the power sports side. We have hydrogen motorcycles that are running today. So this is kind of that launching platform to get to that next level engine for cleaner emissions and reduced carbon. So this engine today is a liquid cooled engine, flex fuel capable, just under 2.4 liters. As I mentioned, cast iron block, it's a structural block, so this block can be utilized in a chassis and be used as a structural member of that chassis as well, making it a very universal fit and make it very adaptive for replacing some of the current engines that are in those size categories today. Gross power, this is the EFI, or this is the E85 variants, 72 horsepower and 95 horsepower respectively, with the naturally aspirated and the turbocharged versions. If we're looking at the E10 version, generally you see about a 10% reduction in power from E85 to E10 standard gasoline fuels today. With this engine, with our electronic fuel injection technology, we're able to customize the torque rise and torque profile of this engine. So using the base map of the torque profile, we're able to adjust the torque to have 10% rise, 20% rise, 40% rise, to give our customers the options to have the power that they need and to be able to maintain that power with that torque rise. So simplified after treatment. I mentioned earlier that this engine uses a three-way catalyst, and that three-way catalyst is a common catalyst that's used in the market today. It's the same catalyst that goes in your trucks and cars, and it's proven, it's known, and it's very durable, and it really eliminates from a comparative diesel that pain point of having to run at higher temperatures to be able to keep the catalyst hot. This engine's made so that it can do start stop. It will be a great engine, and you don't have to rely on waiting for those regen cycles to be completed. It's an engine that's just going to run and run well, and it's going to run well in cold weather as well.